Here we have an interesting geometric challenge where we have to find an ellipse with this particular segment AB given to us as the axis and this line given to us as a tangent. First of all, we are going to establish how many such ellipses exist. So let us look at the family of ellipses with AB as the axis. So this would be the family of such ellipses. You can imagine this to be different positions of a balloon being inflated with two fixed points A and B, and you'll realize that only at a particular size or phase of inflation of that balloon it is going to touch the given line, and therefore this ellipse is going to be unique. So our solution is one and only one. Okay, so now let us look at the steps. First we are going to draw this circle with AB as its diameter. Then we are going to extend the axis AB, and we are also going to extend the tangent given to us so that they intersect at point I. So I is the point of their intersection. Next we are going to mark the center of the axis, which will also be the center of our ellipse. And then we are going to draw a semicircle with CI as the diameter. Now we know that angle included in a semicircle is a right angle. So we are going to mark this point of intersection of the semicircle and the circle, which is T dash, and this angle CT dash I is going to be a right angle. But C is the center of this circle, T is a point on it, so CT dash is the radius, and perpendicular to that will be a tangent. So in other words, we have constructed a tangent IT dash to this circle. You might have guessed what we are going to do. Ellipse is really nothing but a compressed circle. So our circle, if we compress in a vertical direction, its diameter AB will remain the same, but its vertical dimension will reduce, and we are going to reduce that vertical dimension, scale it down till it becomes tangential to this given line. Okay, so let us see where it will be tangential. For that we are going to project this point T dash onto the tangent. Of course we'll be doing this perpendicular to the given axis, and then we are going to project this point T horizontally or parallel to the given axis onto this radius CT dash till it meets at point M dash. Then we are going to draw a perpendicular to the axis from the center C. So the other axis is going to be somewhere in this direction. We don't know its length yet, but that's the general direction. And then we'll be drawing an arc with C as the center, CM dash as the radius, and this arc will intersect the perpendicular that we had drawn, the general direction of the second axis, at M. And that completes our problem, because now we know the semi-minor axis CM and the semi-major axis was already given, say CB, and knowing the two, we can of course draw an ellipse. So this is our desired ellipse.